Hi, today I would like to present you an enhancement I brought to the tool I shared with you a couple of weeks ago. And in the comments I got from John Taylor from the UK, the electric Brit, he suggested to have the quadrilateral characteristics for ground protection shown in the tool. So I did this and I would like to show it to you. So here you can see the tool as I showed it to you a couple of weeks ago, and in this tab here called Z chart you can select the ground characteristics, which can be MHO or QUAD. If you click on QUAD, you've got the quadrilateral that appear on the impedance plane. Here you've got some handles that you can change the angle. Here you can see on the right hand side or the left hand side. You can as well change the reach on the left hand side or the right hand side, and depending on the load you would make changes. What I have here is 3 zones for quadrilateral. So at this stage it just mimics the 3 zones, so you cannot select and different resistive reach for the quad at this stage, but I plan on doing this. So here you can see on the right hand side you've got the load impedances, the 3 quads. Okay. Here you can manually input the data here on the left hand side. On the left hand side here, if we change the current and voltage, you'd expect to have, for an edge ground fault for example, you would bring down the voltage, right? And you can see that it's color coded still, so you can see that now with the voltage being dropped, you've got already the ground characteristic being on the tripping mode on the 3rd zone. Typically what you'd have is a current that would be lagging by the line impedance angle, but for a resistive fault you've got your resistive fault that just adds to it, so the current is not as big as it would be, and as well the angle would not be as big. So here the line angle is 80 degrees, so if we just, for illustration, just illustrate a resistive fault on the A ground, you would basically have something like this. You can see like 16 degrees here with the 6 amps, and you can see now that the ZA is already triggered on the triggering phase for the Z2. If I increase a little bit the current, you can see that the quadrilateral on the Z1 is already triggered for ZA. So you can see that you have a better resistive reach as compared to the MHO characteristic. So this is the change I made, so you can have a play with it. So here as well I've just made a change. You can instead of having phasors, you can have like the dots for each impedance positions in the impedance plane. So go have a edit and just play with the quadrilateral characteristic and see for yourself how the MHO and QUAD are behaving for different types of faults. I hope you like it, and look forward to have your comments. Thank you.